good to be here. My name is Daniel Rosenwasser. I'm the product manager on the TypeScript team at Microsoft. And today I'm going to talk a little bit about what my team's been working on the last year or so, where we've been working on a 10 times faster native port of TypeScript. Fun fact, I actually was here about 9 years ago. Looking back at how things have grown and changed in that time is kind of extraordinary to me. 9 years ago when I was here, it was a very different sort of feel of like who was using TypeScript, who was looking forward to using it. There's a bit of skepticism still within the community and ecosystem. So just by show of hands, if you're using React today, how many of you are also using TypeScript? OK. And who is not using TypeScript if you're brave enough to raise your hand? Actually, nobody in the crowd. OK. So it was not the case 9 years ago if I would ask that sort of question. And you're starting to see that become more and more the case, that TypeScript is kind of the default way for everybody to write JavaScript apps in general. So this is the State of JavaScript survey from this past year. And it basically says about 3/4, like 75% of most JavaScript code actually is TypeScript development, right? And we see this sort of thing in a lot of different surveys and data sets that are released publicly. Stack Overflow survey doesn't exactly tell us that, but it tells us that most people use TypeScript, like it, and it's the third most used or something around that. But in the GitHub Octoverse rankings, GitHub has released that basically TypeScript was the number 3 language back in 2024, right? And 2023 as well. So it really held that spot, and that was very impressive for us. But what's interesting a little bit about this chart is that JavaScript actually falls to the number 2 spot, while Python takes over number 1. And part of that is definitely that Python is growing, but we have like this theory that, in part, this is because TypeScript is actually becoming more and more used as the way to write JavaScript, right? So it's not that JavaScript is falling in usage in any capacity. It's just that if you combine these two, it's just growing, and TypeScript is growing into part of that. So they're very interlinked. But this is from a year ago. In the most recent version of this report, TypeScript took the number 1 spot. It is the most used language on GitHub, with a small hypothesis that this is maybe from AI-generated code as well in some capacity. But I think it is actually just really extraordinary because this is something we never would have thought about 10 years ago, definitely, even last year, 2 years ago either. So this is pretty extraordinary. If it's also because of vibe coding and stuff like that, I don't know. I mean, it's possible. But if you think about it, that's more of a reflection of how people are just doing development today anyway. Because AIs are sort of trained on whatever we're all doing. And if TypeScript is the best way to do web apps or apps in general, like that's the choice. And it's a nice guardrail, too, because if this thing is making stuff that you not need, if you need to make sure it's actually generating sane code, it's going to be a good guardrail for it, too. We have a great community. We have an extraordinarily rich type system. It's able to do a lot. It's able to express so much. It's also got great tooling. So like if you're in VS Code or a similar editor, we have a language server that powers all of those operations. And so by and large, like we've got these things. We've got a great API usage tool, linting, all that stuff. But as we were developing TypeScript, we started seeing that we're starting to hit the limits of JavaScript, right? I don't mean like we're hitting the limits of like the language being able to grow on JavaScript or grow JavaScript itself. I'm talking more about we're building TypeScript, and TypeScript is built in TypeScript. It's called bootstrapping or dogfooding or whatever. But you build your own compiler and language in itself so that you get a good sense of what it's like to use that language, right? And so when you do that, you get a better product overall. But at the end of the day, TypeScript compiles down to JavaScript. And when you run JavaScript, JavaScript is not necessarily a great language for building compilers in. Not from an expressivity standpoint. It is actually a great language for building compilers, especially if you have types, but not for the speed, right? Because JavaScript was built as a language to sort of respond to UI events and things like that. it was not meant for high throughput computing. It was not meant for going through millions of lines of code in the shortest amount of time possible. And the V8 runtime, the thing that runs in Chromium, the thing that runs in Node.js, it's incredibly sophisticated, but at the end of the day, it can only do so much in a certain amount of time every time you start up your program, right? At the same time, I don't know how many of you have seen this, but many of us were kind of like shocked when we saw this web page a couple of years ago. This is a recording from the ESBuild website. And this is a recording of this comparison that they had of what if you look at this tool that we've built compared to Terser, Rollup, Webpack. Look at how much time you're spending compared to if you switch to this tool, right? This thing is literally over 100 times faster than what you're probably using for a lot of your builds. And that shocked people, right? And the idea was, hey, maybe the JavaScript tooling doesn't need to be built in JavaScript. It can be built in a native language. So on our team, we're facing a lot of challenges, right? We have these increasing sizes of projects using more and more sophisticated parts of our type system, which takes a lot of time to compile. And it takes a lot of memory, too. So one of the most common reasons that we start crashing is that there's out-of-memory issues, right? This is especially the case in VS Code, which is an Electron-based runtime, and there's a 4 gigabyte limit. And if you have a 4 gigabyte limit, basically, for a very, very large monorepo of millions of lines of code, it's actually really easy to hit this. And the more analyses that we do, the more powerful we make TypeScript, the more we have to do. So it's slower. I don't know. Like it just takes more time. And whether you like it or not, you're gonna hit it because these analyses don't always just know that something is happening, right? So you have these analyses whether you're opting in or not. You don't pay to play. And so, as an example, if you took the TypeScript compiler from 7 years ago, you compile it with itself, and then you take the most recent TypeScript compiler, then it takes more than twice the time because now we're doing these new analyses like control flow analysis and narrowing and all this other stuff too. And then you throw in other demands, right? Like our editors need things to happen really quickly, and so do the AI agents so that you have like something where you can get in under 200 milliseconds so things feel snappy, right? And meanwhile, there's just this like tooling renaissance in the JavaScript space, right? There's all these native tools. So there's pressure, right? You've got ESBuild, you've got SWC, and they're all over 100 times faster to build. And we do our best to try to optimize this for a while, right? Like we try to, even to access a property in JavaScript is sometimes a slow operation, relatively, just because there are so many edge cases of like how your data could be laid out and things like that. It's also hard to control like how much memory you allocate. This is especially the case for like arrays and strings. You can't just work on like a subset of a string or an array. You always have to have like a temporary object created for this sort of stuff. And it's hard to benchmark. So even if you have something you think is a good improvement, running a JavaScript runtime in like a VM to try to see if something is faster is just hard. And at the very end, like as much as we were doing, we were hitting maybe 10 to 20% improvements in the best cases, right? This would excite us, but it was never going to get us a 2x improvement across the board for speedups. And sometimes we'd have extreme cases we would do. Meanwhile, we can only do one thing at a time, right? So this is JavaScript. You get one thread by default. Maybe you can get more threads, but then you have to start doing async await, right, or promises. And we are currently built in a synchronous way. So if we did start to do some of this stuff, like we have an issue with loading the program, like all your files, where you have to do a parse. You start parsing the file, then you look at what it imports, you try to load it on disk, you see where the import goes to, you read the file, you parse each of those files, but each of those is sort of blocking the next step. It's like the waterfall issue in rendering in React. So we could improve some of this stuff. It's usually not the bottleneck, but we would have to do async await, which would break our entire API. And it still doesn't give us parallelism, even if we do that, right? So if you want to start adding parallelism, you need threads. So you have workers in JavaScript. With workers, you can either transfer your objects over, which is a full copy, or use shared array buffers which is like not something that anybody does. So you don't get shared memory by default. And if you really try to, you'd have this very impractical thing. Like this, nobody basically makes a program that's just on a flat array of bytes. It's just insanity. So maybe there's something on the horizon called shared structs, where it feels more like actually writing JavaScript to have shared memory between different threads. But that's a couple years away, right? So we keep getting this question: when are you going native? Right? Rewrite it in Rust. There's like this elephant in the room. I don't know if this is a common expression here. Hapil b'cheder, hapil b'pina. Okay, yeah, like there's an elephant in the room. Everybody sees it. Nobody wants to say anything about it. But all of our users are saying, "What are you going to do about the elephant?" Right? And so we really resist this because we really try to push on the idea that we can kind of make algorithmic improvements. But it's just like also a very common piece of advice is don't rewrite your product if you can help it, right? Because if you look at examples there's an article from Joel Spolsky, basically in the article, things you should never do, he says rewriting the code from scratch, right? And he uses the Netscape code base as an example, I think. And the reason is because two things, right? One is you forget all of the good things that you put into the original code base because for years you had all these bugs, these issues that you've basically solved. You put a lot of investment into it. And you forget, oh, I'm going to have to solve these things all over again in a new architecture because maybe I haven't tested this thoroughly and things like that. But the other reason is because the world continues to move on without you, right? So if you're going to do a full rewrite and you have to reconsider and come up with the most ideal architecture, if you could do it all over again, 3 years later, everyone says, like, whatever happened to that thing? Or your competitors come and eat you and all your users switched over to them, right? So the key thing was we kind of asked, what if we didn't rewrite from scratch, but we could think more in terms of what if we could port the software over, right? So he said, what if we actually did do this, right? We'd be looking for optimized native code across all platforms, Windows, Mac, Linux, every architecture, and WASM preferably too, so you can run in the web. We have a playground that people use to learn TypeScript. We wanted it to be memory safe, so like all of the issues and RCEs, like vulnerabilities, whatever. I mean, like it's a compiler, but we didn't want to have to worry about all the issues that you have if you use C++. Not to knock on C++, but yeah. But really, the big one is to preserve the structure of the code base, right? Like, we want to have basically the same code with as few changes as possible so that you can kind of conceptually take what's there and not do a full rewrite, right? So it should look as close as one-to-one, so you always looks like that you're basically doing the same coding. And if your code looks the same, all your data structures need to look the same too, right? Which means that like all of your interfaces and types and whatever have to be similarly representable, right? So that also kind of includes not having to think about like, oh, I can't represent pointers in my language that are circular, right? I need to have cycles. I don't want to have to think about different pointer types, for example. So like if this is allocated in this way and then I pass it to you, who deallocates it? That's also not a problem we want to think about, which kind of means that we need a garbage collector, right? We need something that actually will do all the same stuff we were doing before. And then finally, if we do native, it's not enough to just be native. You also need to actually take advantage of the capabilities of modern architecture. So there's a paper from about 20 years ago called The Free Lunch is Over. And the free lunch there is basically that for years, everybody's relying on hardware to get twice as fast every few years. And that way, you can make software twice as bad every few years. And then everybody's like constantly just as unhappy, and it evens out. But really, the whole thing is that you're no longer getting improvements on just single cores. Like cores are not getting faster. You're just getting more cores for the most part. With the exception of like, the M1 MacBooks and everything like that really like changed the game. I'll just give them credit where it's due. But yeah, so we needed that. And realistically, that gave us like 3 options that we were thinking about, right? There's more, but there's Rust. Everybody told us to rewrite it in Rust, so it felt like the thing that, I'm getting like nods, like people are like, Rust! And that's great. I think it's a great language. Doing it all over again, maybe, I don't necessarily know. But I think for the reasons I just explained, it's not a straightforward port if you decide to do that, because there's all these issues with how you represent your memory. The borrow checker is more restrictive in a lot of ways. So we definitely needed something with garbage collection and something that was friendly to our model of representing memory. C# was also a pretty good option, right? The lead architect who worked on our team also was the lead architect on C#. So we know a lot about it. But at the end of the day, I think a big part of this came down to being able to represent our code base in a very similar style, right? Like, it tends to lean a little bit more object-oriented. We tend to be a little bit more procedural in how we do things, top-level functions, immutability by convention, things like that. And so at the end of the day, we went with Go. It is the language that we saw ES-Build itself was built in. So we had a very good inkling that, hey, you can optimize your code really well in this language. And overall, I think it's gone pretty well. So our lead architect decided, not actually knowing Go, decided to start porting over the first two phases of our compiler. The tokenizer, the scanner is what it is called up here, and the parser. And so this was back in about August of last year. Took about a month and a half, 2 months, and finally got a working parser that could parse all the TypeScript code in the TypeScript compiler. And he got about a 3.5 times speed up, which was pretty good, and that we're pretty compelled with that. But then he threw just threading at it, like Go routines, just use all the cores that you can, and we easily got over 10x. And so then we were like, okay, now it's really happening. So today we have a type checker that's complete. We have, by the way, it's a React conference, so we have JSX support since we first came on the scene. We have JS support too. Our emitter is in progress, so actually outputting JavaScript files. So in the next month you can expect that. Build and incremental modes, they're done, but they just could be faster. Our language server, the thing that powers the support in VS Code and similar editors, now uses LSP. If you know what this is, it just means if you don't know what it is, it just means that it works for more editors in a more plug-and-play way. And it's 10 times faster and uses a quarter less memory, at least. It's all public. It's all open source. You can go to this repo today. That's where we're iterating on it right now. And I'm going to hammer this home a couple of times, but please give this a shot. It is ready for you to try out in your project at the very least. We have a VS Code extension that you can all use. And if you want, you can also try using it, and you can try using a compilation. We're published to NPM through that. This QR code goes to the blog post where we announced it, so it's a little older, but it gives you the right resources and pointers to go there. If you miss this, I'll have this slide again. But basically, let's just show you what I'm talking about here. So I have a code space here. Oh my gosh, what's going on here? Don't do things while I'm demoing. OK, I have a code space. I have a code space because it gives me 32 cores, and it's faster, and you can see more stuff happening, which makes me happy. So I can run the TypeScript compiler here. Let's just do -v. This says the version that we're running off of. I don't know why it's taking so long, but we're on TypeScript 5.9.3. And the repository that I have open is actually the VS Code repository. So the editor that I'm showing now, I've opened up the source code of that editor, right? That's where we are. So I'm going to run tsc-p, so that compile the source directory of the VS Code project. And I'm going to say extended diagnostics. And it's case insensitive, so I don't have to worry about that. So we're just going to run that. And what you're going to notice here is that none of the cores are being used except right now it's core number 5. Because this is the existing TypeScript compiler. It's JavaScript. So we've got a single thread that we're running on, and we're doing as much work as we can, but you can kind of feel it. So in the meantime, let's open up arrays.ts. OK, so this is a helper file here. And you can see at the bottom of VS Code, it says initializing source/tsconfig. And so it's going to take at least 10 seconds, 20 seconds, maybe 30 seconds, depending on your computer. And what that means is it's loading up all the files of your project before it can do a full request. So then I can do find all references, and I can just navigate around there. I can get completions, and it's accurate and things like that. But we only get to use one core at a time when we do that, right? So it's a little bit of a shame. Let's close this out just so we're not too distracted. This thing is still running, right? So this is kind of what I mean is like people are just waiting over a minute for this thing to compile. In this case, 67 seconds, right? So with our native previews, with a port that we have a new executable called tsgo when you install the package. It works exactly the same as tsc. It's just called that because you should be able to use them distinctly and have them installed side by side. So this is one of the recent nightly publishes. And I'm going to do the same thing with tsgo instead. And I'm going to open up htop again so we can see our cores, right? So they're all just doing nothing. They're all doing something now, right? They're all completely saturated. When they've stopped, that means we've stopped parsing. That's how fast it was to load up all of the files in the VS Code project. Thank you. That's 1.5 million lines of code, by the way. And so the checking phase, we're not perfectly parallel there. We do have some knobs so you could do that. So you could say checkers, let's say 16. So it took about 9.5 seconds or so, or like 8.5 seconds just from like before we reported all of the stats. So now, wow, okay, it took 5 seconds basically. And what I did there is I said like, okay, we don't use as many checkers as you have cores. We use 4 checkers by default because we don't want to use too much memory. But you can say, hey, I've got 32 cores, use 16 checkers or something like that, and use as much memory, I don't care. And it'll be much faster in some cases too. So this is the sort of speed up you can kind of expect. Also, let's go back to this file really quickly. Let's open htop just so you can see. So I showed you that this took about 10 seconds to fully load. We also have an extension called the TypeScript native preview. So if we enable this thing, it's just done. It's like, as soon as I hit that button, it was completely loaded, right? So I could do find all references here, and it's instantaneous. I'll just restart it. And then let's find all references. It just works. Let's just request completions, right? Basically, you don't even think. As soon as you restart the language server, I guess some people do because something's wrong occasionally, it's just loaded. So this is the new experience. For on 1.5 million line of code base, you're just like there. I'll also show you the TypeScript compiler really quickly because this is a multi-project workspace, right? So I'm going to disable the extension. You can see that this one takes less time to load the first project. But then if I do find all references here, 1, 2, 3, OK. So what it had to do there is it had to actually like go through all of the projects that reference this thing, open them up, and see who calls into this symbol, into this variable. I'll do the same thing here. Enable it. It's already ready. I can immediately ask for all references. It took less than half a second. So yeah, thank you. So now we get to have a chart like this too, right? You get to see the after and the before, right? We're done. We're still waiting. We're still waiting. We're still waiting. So VS Code and Sentry. Sentry is an open source code base you can also take a look at. It uses React. These are both about 1.5 million lines of code. And it's about 7 to 10x speed up depending on your hardware. For the projects below, they all take like a second or less. So compare that between like you're waiting 17 seconds for a full build, and that's not even incremental, right? That's not even like using the optimizations between. These are clean builds, right? So you'll see this again, but I really want to hammer home. Like I just showed you this thing working. It's stable. You can use this without bothering the rest of your team because there's an extension. You just install the extension in VS Code. It works. You're happy because it takes less time to load all your projects. Your computer's happier because it has less stuff that it's doing overall. But less time to go get a coffee. I'm sorry. Like there's no I'm compiling my code excuse anymore. So I told you that we were porting the code. So this means it has to look exactly the same as much as we can make that true. Here's an example of one of the functions from our compiler. This is in TypeScript. This is what it looks like in Go, right? So basically, you can see a lot of examples of this sort of thing in our code base where like you put them side by side and you're like, okay, this is basically the same thing. Occasionally it looks a little different, but you basically can eyeball these things and feel confident that you're just porting code over. So I told you we're porting, not rewriting. We did the first 2 phases of the compiler by hand. This was partially to get a sense of what it would look like. And once we understood what it would look like and what our data structures were actually going to be represented as, we realized that a lot of the stuff was very mechanical. So we do the thing that nerds do, which is we automate the thing that we kind of like are sick of. So my colleague Jake, he wrote this ts2go tool, which basically takes code from the TypeScript compiler and does a bunch of hacky rewrites and spits out Go code. And it doesn't necessarily work. But what you can do is whenever you have a function that you want to port over, you can look at the thing that it generates, copy and paste it. A lot of the time it works. If it doesn't work, you massage it a little bit by hand. And then usually what happens is you're missing a couple of other functions. So then you go back to the generated code, you copy and you paste it, and you do this over and over and over again. And it sounds silly, but it actually is like the thing that made a lot of this faster, like legitimately. Apart from having like over 20,000 tests to run off of. So a lot of people at this point ask, like, why didn't you just use AI if you have a mechanical task you don't like? And it's because you can't trust them, right? Like you can, they're getting better in some cases, you can review it, but if they're always making the same types of mistakes, and then you're like, oh crap, I forgot to tell it about this specific thing not to do whenever it ports code, we have to start worrying about prompts and inconsistencies. And so there's a whole thing about stochastic versus deterministic. Basically, can you repeat the results of AI? And you can't always. So what we did is, instead of having the AI do it, we had the AI work on the program that auto-translates everything for us. So as instead of using like Copilot or Claude or Codo or like Codex, they all start with K. I don't know why. But instead of having it do the translation, we had it help us with the thing that did the translation. And you always get the same consistent result as a result of that. So from going to Go native, right, like we got easy multi-threading. We didn't have to think about async await at all, because Go just implicitly does this as soon as you create something called a Go routine, which is honestly very nice. There's trade-offs to it, but like for us, it was kind of perfect. We also don't have to worry about allocation, right? Like we have more fine-grained control about allocation, and even when we don't, the Go compiler has more time than a JavaScript JIT engine to try to figure out what the escape analysis and all that stuff. Also working on strings and arrays, which a compiler tends to do a lot of. It is great for that because these things take up space the way that Go does like arrays, more or less, but it doesn't allocate necessarily. So you can manipulate and work off of arrays really easily. And data access is not pay for play, or it's more pay for play for abstraction. So all of this is going to become TypeScript 7.0, right? The native TypeScript compiler is going to be 7.0. And a lot of you might think, like, what are you talking about, right? If 7.0 is the new compiler and 5.9 is the current one, what the hell is in between? So this is where TypeScript 6.7 comes in. And so we have TypeScript 6.0, which is basically going to be a TypeScript-based code base. It runs in the JavaScript engines, like, directly. It's the same foundation as 5.9. And it adds a lot of modernization, like things that everyone's been asking for TypeScript to do for a long time now. But it also contains deprecations, because in 7.0 we actually don't want to port over certain features that like nobody is using necessarily either. It's still the thing that you will probably use for the current TypeScript API. I'll get into that in a bit. But the target there is to come out with this in February of early next year. So 7.0 is the new Go-based code base. Go-based code base. Let's see if you can say that a lot, really fast. And it's compatible with 6.0. It drops whatever 6.0 deprecates. And it is, unfortunately, it doesn't have an API, right? We're working on it, but we're basically planning to get this out about 2 months, 1 to 2 months after 6.0 goes out. And the idea is to keep them very tight and close to each other so that there's no divergence between the code bases. They should be compatible with each other. And so, of course, you might say, like, well, hold on. You just said, like, no API in the new thing. And yeah, it's a problem, right? Because tools like Prettier and ESLint, like TypeScript ESLint, actually rely on this API, right? So what you'll probably have to do for a while is actually use both of these things side by side, right? You'll have to use 6.0 for anything that's API related, but then for 7.0, you can use this in your editor, and it should be compatible so it just works, right? You can just start using this. You can use it for building and compiling, but you may need to have these things side by side for a bit. The plan is for 7.1 to have an API. We didn't want to block on this because we wanted to get this in people's hands because it is useful now. But even now, we're seeing some really cool experimentation with some tools relying on like our internals. Stuff that you should know about for TypeScript 6.0, we are making some deprecations to options that we just either don't think people use anymore or shouldn't be using anymore. Using the nightly versions of 6.0 is a good way of getting a sense of if 7.0 is going to have issues. But you can also just use 7.0 nightlies too. And then we're going to have strict by default soon. So this is a thing that a lot of people have been demanding for, and also admitting to the latest targets on TypeScript by default. So TypeScript is going to now become more easy for newcomers to start adopting, and we'll have some more details on this in the future. So when can you use this in your project? Like I said, hopefully early next year. But truly, like now, you can start using the early previews. I'll say this is the third time I've shown you this slide. Go try it out. Give us the feedback because we have over 20,000 tests. Yes, we're using as much as we can from the community, but we do need people to try this out. So try it out. Thank you so much. Give it a shot, and thank you all for having me today.